Alright guys, so we are going to be looking at the answers to the notes that dealt with oblique asymptotes. In this case, you guys were looking at 3 and 4 in that section titled oblique asymptotes. In that first one, because I had a leaded coefficient 3, I decided to do long division for this. And what I got is I got a remainder of negative 11, and then I got 2x to be my oblique asymptote, y equals 2x. In this case, because I had x minus 3, I was able to use 3 with synthetic division, and I got 3x plus 2 to be my oblique asymptote. It does have a remainder of 6, but that's not going to impact what your oblique asymptote is. So what we're going to do is we're going to look at the idea of finding x and y-intercepts of the graph. It's the same with anything, really. The first thing that we want to do usually is we want to find out what the y-intercept is, because I'm plugging 0 into the original equation. I'm not canceling anything. I'm always just plugging it in. Once I find that y-intercept, then I can start working with finding the x-intercepts. And there's like 3 steps that we have to do. We're going to have to cancel or factor the numerator and the denominator. That's going to be the first thing when we want to find x-intercepts. Okay? This is the steps to find x-intercepts. The second thing that we're going to do with that is we're going to cancel the numerator and the denominator. Okay? Anything that's common, we're going to cancel. And then to find the x-intercept, we're going to set whatever the simplified numerator is equal to 0, and that's what our x-intercept is going to be. So let's look at an example. In this case, I want to find out what the y-intercept is. So I'm going to plug 0 in place of x. So I got 0 plus 1 over 0 minus 5. I do get 1 over negative 5. So in this case, my y-intercept is going to be 0, negative 1/5. Now, if I look at this, if I look at x plus 1 divided by x minus 5, there's nothing that needs to be factored. So, like step 1 we found, step 2, I don't have to factor it. Now, what I have to do is I don't have to worry about canceling in this case because I have nothing to cancel. Now, we want to find out what the x-intercept is. So we're going to set whatever's in the numerator equal to 0, and you do get x to be negative 1. So in this case, it does have an x-intercept. It's going to be at negative 1, 0. Let's look at another example. So we're going to look at question 2 under x and y-intercepts. All right, so first thing we want to do is find out what the y-intercept is. So we're going to plug 0 in place of x. And I do get 3 over 2. That's because 0 plus 3 is 3. 0 plus 2 is 2. So in this case, I do have a y-intercept, and it's going to be at 0, 3 over 2. That's your y-intercept. So now I want to look at step 2, factoring the numerator. Does that factor? Yes, it does. I get 3 times x plus 1 divided by x plus 2. So it is factorable. Now, is there anything to cancel? No, I don't have to worry about that. Now I can find out what the x-intercept is. So I can do 3 times x plus 1 equal to 0. So really that's x plus 1 equal to 0 because the 3 cancels. I get x to be negative 1. So in this case, it does have an x-intercept at negative 1, 0. All right, let's look at this next example. You got x squared minus 2x minus 15 divided by x plus 3. Well, y-intercept, we're going to plug 0 in for x, so we're going to do 0 squared minus 2 times 0 minus 15 over 0 plus 3. So I have a 3 in the denominator. It looks like I got a negative 15 on the top. That simplifies negative 5. So I got 0, negative 5 to be my y-intercept. So I got that taken care of. Now I want to try to factor out the numerator and the denominator. Is that factorable? Yes, it is. I can factor out the numerator and denominator. Is there anything that I can cancel in the numerator denominator? Yes, I can cancel out the x plus 3's. So, in order for me to find out what the x-intercept is, the x-intercept is going to come from that x minus 5. So I'm going to set that equal to 0, and you got x to be 5. So in this case, it does have one x-intercept. That's going to be at 5, 0. Actually, the interesting thing is that the x plus 3 is going to be that point of discontinuity, which is going to be negative 3 in this case. All right, so let's look at this next one. All right, finding the y-intercept, that's what we want to find first. So we're going to plug 0 into this equation. So I got 0 minus 3, and then I got 0 squared minus 5 times 0 plus 6. Well, it looks like I'm going to get negative 3 over 6, which is negative 1/2. So in this case, I do have a y-intercept, and it's going to be at 0, negative 1/2. So, got that y-intercept. Now we want to factor out the denominator. So if I factor it out, I get x minus 3 divided by x minus 3 times x minus 2. That's what this factors out to be. The x minus 3's cancel. So is there anything else in the numerator? So I've got the canceled, I factored it, I found the y-intercept. Is there anything else in the numerator? There is nothing. So in this case, there will be no x-intercept. None. Not. Okay, there is nothing. There is no x-intercept in that case. There is a point of discontinuity, and that's going to be at x equals 3, but there is no x-intercept in this case. So your job, if you choose to accept it, is hopefully to try these 3 questions, in which I'm asking you guys to try to find what the y-intercept is as well as the x-intercepts are. Hopefully you guys are able to do that, and we will talk more about that in a little bit.